Hello everyone, in this video I'm gonna solve IBHL Mathematics Paper 2 questions from this year May examination. This is time zone 1, which is taken in the Americas. However, this video is not only for IB students but also for anyone who are interested in this kind of topics and preparing for high school or university level similar exams. Let's start with the question 1.
Question 1. The points A and B lie on a circle with center O and radius 19.5, such that BOA angle 210. A piece of paper is cut into the shape of the sector BOA. A hollow cone with no base is constructed from the sector by joining the points A and B. The sector forms the curved surface of the cone. This is shown on the following in the following diagram. Find the area of the sector BOA. Yeah. The area of the sector, I know that it equals area of BOA is gonna be theta times r squared over 2. I know the angle is 210 degree. I'm gonna convert in the radian, so you can convert in the radian uh, by multiply pi over 180, and from here let's cancel 30. So it's gonna be 7 pi over 6. I'm gonna replace theta with 7 pi over 6 times, and the radius is 19.5. 19.5 square over 2. Let's find this. 7 pi over 2. So 7 pi over 6, right? 7 pi over 6. 19.5 square. 19.5 square over 2. It is approximately 697. 697. Question B. The radius of the cone. It asks for the radius of this cone. And I know that the perimeter of this AOB, which is 2 pi times radius of the big circle here, 19.5. But the angle is 210. So I will multiply it 210 and divide it by 360. So this is the perimeter of this arc, we can say, and it's gonna be equal to the perimeter of the base of this cone. In this case, we can write 2 pi times r, the small r, let's say. You can cancel 2 pi from here, and r equals, and also cancel 30 again. You can write 7 and 12. 19.5 times 7. 19.5 times 7 over 12. It is 11.4. Yeah. Question 2. Consider the function f of x equals alpha times tangent 2x plus b, where x does not equal to n plus 1 pi over 4 and is an integer number and ab real number. Write down the period of f. I know that the period of f is equal to pi over the coefficient of x, which is 2 in here. Question B, the graph of f of x passed through the points. There are 2 points in here. Find the value of alpha and the value of b. So I know that when I plug in pi over 12 into the function, the output will be 5. In the same manner, if you replace replace x with pi over 3, the output will be 7. So I will do that, and our expression of the function is given alpha times tangent 2x plus b. So alpha times tangent 2 times pi over 12 plus b equal 5. And the second one will be alpha times tangent 2 times pi over 3 plus b equals 7. The first one is, I know it, alpha times tangent pi over 6 plus b equal 5, and tangent pi over 6 equals square root of 3 over 3, or you can say 1 over square root of 3 plus b equal 5. And the second one, I know that the tangent 2 pi over 3 is at the second region, which will be negative sign, and the value of this angle will be uh, minus square root of 3 plus b equals 7. So I can write b equals 7 plus square root of 3 times alpha. I will replace this with b at the first equation. Uh, Alpha over square root of 3 plus 7 plus square root of 3 times alpha equal 5. And you can write, mm, if you add the like terms in here, I mean combine the like terms, you will see that 3 alpha plus alpha over square root of 3 equals minus 2. And from here you can write alpha equals minus square root of 3 over 2, right? And the second one will be b equals 7 plus square root of 3 times minus square root of 3 over 2, and which is 7 minus 3 over 2, 11 over 2 equals 5.5. And let's find alpha. Square root of 3 over 2. It is 0.866 minus 0.866. Yeah. Question 3. A population P has a rate of change modeled by dp over dt equals minus 104,000 times e to the power of minus 0.0145 times t, where t is the time measured in years since the start of 2022. At the start of 2022, the population was 6.78 times 10 to the power of 6. Based on this model, find the predicted population at the start of 2026. You can find either the change in the population in 4 years by using the definite integral, or you can just find the function of p. I will use this one to find the function of p. In this case, to find this function, I need to find the integral of the rate of change, okay, in terms of t. So you can write the constant out of the integral, which is 104,000, and integral inside, you can write e to the power of minus 0.0145 times t. So let's find this integral. And the integral of the function e will be equal itself. I will just divide it by the power, and there's a constant c in here when we find the integral. So to find the constant c, there's information in the question that the initial population was this number. So when I substitute t with 0, which means at the beginning of 2021, the population will be 6.78 times 10 to the power of 6, right? So what is this? This is minus 104,000 times e to the power of 0 over minus 0.0145. And from here you can say that c equals 6.78 times 10 to the power of 6 minus 104,000 over 0.0145, right? Yeah. So how about the population at the start of 2026? It means after 4 years, in this case, I will replace t with 4 in the function pt. So it will be minus 104,000 times e to the power of minus the same number, but don't forget to write times t in here, right? In this case, I will multiply it by 4, 145, and I know that the constant c, we found it, the number in here. So we're gonna calculate this. Yeah, it's gonna be 104,000 over 0.0145 times e to the power of uh, e to the power of 0. Make sure to write in parentheses 0.0145 times 4 because there's multiplication in here. It's times 4, right? Yeah. Plus 6.78 times 10 to the power of 6 minus this number. Yeah, this is the population. 6,375,375,000 834. Yeah. Question 4. In a study, measurements for arm span, A centimeter, and foot length, F centimeter, are taken from a large group of adults. For this group, the regression line of F on A is found to be F equals 0.335A minus 32.6, and the regression line of A on F is found to be A equals 2.89 F plus 99.3. Each regression line passed throughout the mean point. Question A. By using an appropriate regression line, find an estimate of the arm span for an adult with a foot length of 19.8. Yeah, it asks for the arm span, so I will use the second equation, which will give us the arm span. The equation is equals 2.89 times F plus 99.3. So we know that the foot length is 19.8. I will replace it with F. 2.89 times 19.8 plus 99.3. Let's want this. 2.89 times 19.8 plus 99.3. It is 157. Yeah. Question before this group of adults, find the mean arm span and the mean foot length. So it's given that each regression line passed through the mean point. It means the intersection of these two equations will give us the mean point. So let's find the intersection of these two equations. I know already F in terms of A, and if I write the second equation in terms of A, we can or we can write the first one in terms of F. Yeah, the first one will be in this case F plus 32.6 over 0.335, which will give us A. And the second equation is already given A. So I will just directly write 2.89 F plus 99.3. So you can find F by using graphic calculations. I will draw the graph of this lines. The first one, you can write x instead of f as a variable, 32.6 over, we have this one. And the second one will be, first write this, right? Yeah. And the second one, 2.89x plus 99.3. So I need the intersection point, so it will be somewhere here, the intersection point. Yeah, this point. The x is 20.9. You can say 20.9. So which is F. And the arm span, the mean of arm span, right, will be the second one, 159.7 or 160, you can say. But you need to write from where you found this values. In this case, you're gonna draw the line of these two equation. So it will be, you can just uh, draw a line like this, and they will uh, there will be intersection at the point uh 20.9 and 160. So you can just write here F, the horizontal line, and the vertical one is will be the length of arm, right? So yeah, make sure to draw this graph. Yeah, the last question. The highest age of adults in the group can be modeled by a normal distribution with mean 163 and standard deviation sigma centimeter. It's found that 88% of the group have a height between 153 and 173. Find the value of sigma. So as you see from here, it's given us the mean of this the group. So when we draw the normal distribution in here, I know that the mean at the middle 163 and the area between 153 and 173 is given us actually 0.88, 0.88, the total area here. And since this range is equal each other, so I can divide this area by 2 and will be 0.424 each. So if you look for the area before the 153, it will be 0.06 because I know that the half of the total area is 0.5. So from here you can say that uh, the the probability of the highest less than 153 equals 0.06. So in TI, actually there's a section, and first I can say to find the sigma, we're gonna use the z-score. What is z-score? You can check from the formula booklet also. It's gonna be 153, which is the number in here, minus the mean 163 and divided by sigma. It will give us the z-score. So how are we gonna find the z-score? In TI, you you're gonna choose the section the inverse of the normal distribution because we already know the probability, so we're gonna need the inverse of the normal distribution. You're gonna just write the area that we found in here 0.06. You will write the area 0.06 and it's already be default on your TI. The mean will be written 0 and the standard deviation will be 1 and it will give us the z-score which is minus 1 point. It's better to write all of this number to not make a mistake while we are finding the z-score. Minus 1.5548. So in this case, sigma will be 10 divided by this number, which is gonna be, let's write in here, 6.43. Yeah, this is the standard deviation. Question 5. Consider the function h of x equals 15 times cosine pi x over 50 plus 15, where x between 0 and 50. The tangent tk to the curve h of x at the point k h of k is shown in the following diagram. Find the gradient of tk in terms of k. So you see that there's a point in here. So the tangent passed through this point too, right? So, actually, this is a definition of the derivative. It will give us the gradient of this tangent. So I will just find the derivative of the function h of x. What's that? It's gonna be 15 times. The derivative of cosine will be minus sine, and inside of the function it will be pi x over 50, pi x over 50. And from the chain rule, I will find the derivative of the expression inside of the function pi over 50. And I don't need to write the derivative of this constant because I know that it is 0. So this is the derivative of the function. You can just maybe simplify this. You can cancel 5 and write to the negative to the out minus 3 over 10 times sine pi x over 50, right? And then I will just replace x with k because I'm looking for the derivative at the point k, which will give us the gradient of the tangent. In this case, it will be derivative of h of k minus 3 pi over 10 times sine pi k over 50. Yeah. Question B. Consider the case where the angle between TK and the x-axis is pi over 8 radians. Find the possible values of K. So it's given us that this is this angle, pi over 8, right? But to find the gradient of this tangent, for example, I need the obtuse of this angle, which will be 7 pi over 8 because the sum of these both angle will be pi. And if you write the tangent of this angle, tangent 7p over 7 pi over 8. It will also give us the gradient and the value that or the expression that we found in the previous question, which is also give us gradient of the tangent. So I will make equality between these expressions and write this one in here. Yeah. How we gonna find this, or find the values of possible values of k? The best way, in my opinion, to draw the graph tangent tangent 7p, right? 7 pi over 8. This is the first one. hmm I will draw a line, and the second one is sorry, here gonna be 50. Here is gonna be 50. In this case, the first intersection is 7.24, 7.24 K1, and the second one will be is gonna be 42.8, right? 42.8, yeah. Question 6, consider the function f of x equals 4 times cotangent x plus sine x, where x between 0 and pi. Write f of x in terms of sine and cosine. And I know that f of x equal 4 times cotangent x plus sine x. And you can replace cotangent x with cosine x over sine x plus sine x. Yeah, you already write actually the function in terms of sine and cosine. And we're gonna draw the graph of f of x. Let's draw that one for cotangent x plus sine x, right? Yeah, and make sure that x is between 0 and pi, 0 and pi, approximately 3.1. So the point of x intersection is gonna be 1.81. 1.81. The graph will pass through 1.81. And since the denominator is sine x, and I know that sine x is 0 at 0 and pi, so here is the vertical asymptote at the line, let's say x equal pi and x equal 0, right? So our graph will not pass through from this line. I will draw it like this, yeah. Question B, find the value of inverse of 2. Inverse of f at point 2. To do that, I know you can also find the value from the graph. If you call it a, for example, it means f of a equal 2, right? So I can find the intersection, the line y equal to with the function. So it's going to be 1.32. 1.32. Yeah, you can just, if you want, clarify or mention that you found it from the graph, right? This is the point that you mentioned. But the next question is given that secant alpha equals 1.5, where alpha between 0 and pi. Find the value of f of alpha. So if secant alpha equals 1.5, which means 1 over cosine alpha equals 3 over 2, from here you can write cosine alpha equals 2 over 2 over 3, right? Yeah. You can find this value. I mean, it's gonna be inverse of cosine at the point 2 over 3. We're gonna find the angle in radian, 2 over 3, right? Make sure to copy this number, not make a mistake while we are finding the FO alpha. FO alpha will be 4 times cotangent alpha plus sine alpha, right? Let's find this. You can write 1 over tangent instead of cotangent plus sine alpha. We forgot 4. So it is 4.32, right? 4.32. Question 7. At 9, a helicopter is located at a point tan 3, 0.5 relative to a point O on horizontal ground. The x direction is due east, the y direction is due north, and the z direction is vertical upwards. All distances are measured in kilometers. The helicopter is flying at a constant height. The helicopter's position relative to the point O is given by r. This is the vector equation, where t represents the time in hours since 9. Find the speed of the helicopter. Yeah, it's given that the helicopter's position by this vector equation. And to find the speed, you can just, for example, find how many kilometers does this helicopter take in, for example, 1 hour by replacing t with 1. For example, if you plug in 1 into this equation, you don't need to write, by the way, look for the initial point. I will just look for how many kilometers does it take the helicopter in 1 hour, okay? So which will give us the speed. So to find the speed, I will just find the magnitude of this vector. Mm, It's gonna be 4 times square root of uh, 10 square plus minus 25 square plus 0 square equals 4 times square root of 100 plus 625, or 4 times square root of 725. Let's find this. 4 times square root of 725. It is 108, you can say. Yeah. Question B. At 10, the helicopter begins to descend. During descent, the helicopter's vertical height decreases at a constant rate of 16 kilometer per hour, and its horizontal velocity remains unchanged. The angle of descent, beta, is defined as the angle between the helicopter's direction of travel and the horizontal. Find beta giving your answer in degrees. Okay, as you see from the vector equation, uh, since the z direction is vertical upwards and it's 0, it means the helicopter is not going in a vertical upwards or vertical direction. Okay, so it's going on the horizontal direction. But at 10, it begins to descend. From here, it means we're gonna look for the angle between the helicopter direction and the horizontal line in here. At the previous question, we found that this the speed of the vector, uh, it is, while it was going in the horizontal way, 4 times square root of 725. But now it's going down with the speed of 16 in an hour. So I can find tangent beta by using 16 divided by 4 times 725. From here, you can find beta equals inverse of tangent at 16 over 4 times square root of 725. Let's find this. Inverse of tangent at the point 4 times square root of 725. It is 8.45. 8.45, yeah. Question 8. Consider the functions f, g, and h defined as follows for t is a real number. FOT equals sine 2 times t plus 1. GOT equals sine 2 times t plus 3. HOT equals FOT plus GOT. Show that HOT equals imaginary of e to the power of 2 times ti times e to the power of I plus e to the power of 3i. Let's check first this complex number. And if you distribute e to the power of 2 times ti in parentheses, you will see that e to the power of I times 2 times t plus 1 plus, and again, we are distributing for the second one, is gonna be e to the power of I times 2 times t plus 3 right? And in this case, since I know that this is the Euler form of a complex number, which is e to the power of I theta equals cosine theta plus I times sine theta. In this case, I know that if there is this kind of Euler form, complex number, I can write directly the imaginary of this complex number, like for the first one, sine 2 times t plus 1. And for the second complex number, I'm gonna write the imaginary of this number, sine 2 times t plus 3. It's gonna be, right? So which is FOT plus GOT. At the second question, write e to the power of I plus e to the power of 3i in the form r times e to the power of I theta. So again, I know that if we write the Euler form in the polar form, right? So this is gonna be the polar form. It will be cosine 1 plus I times sine 1 plus for the second complex number cosine 3 plus I times sine 3, right? So if you combine the real part and the imaginary part of this complex number, you will see that the part with cosine will be the real part, and the expressions with the I and the coefficient of I will be imaginary of this complex number. So I would like to write this in the form again at Euler form. So how we're gonna write this? First, we need the radius of this complex number. So the radius is gonna be the square root of square of the real part, square of the real part, plus square of the imaginary part. We first gonna calculate this. Cosine 1 plus cosine 3 square, cosine 3, right? Square plus sine 1 plus sine 3 square, but this will be in the square root. Yeah, so it is gonna be 1.8. This is, yeah, the radius of the complex number. So we need now the angle. We call it the argument of the complex number, and which is tangent theta equals imaginary part divided by the real part. From here you can write theta equals the inverse of tangent at, yeah, this fraction. Now we will calculate this. Inverse of 10 sine 1 plus sine 3 divided by cosine 1 plus cosine 3. Yeah, this is the number, but make sure the part or the region of this complex number. In which region? I know. Uh, we now we're gonna find the sign of the real part and the sign of the imaginary part. So I will write the angle in here, but it can be changed because it depends to the region of the complex number. Yeah. So first check for the sign of the real part, cos 1 plus cos 3. So I know that this is negative, and sine 1 plus sine 3, this is positive, so it means it is at the second region. So I cannot take the angle with negative because in this region it's gonna be the positive. So what can we do? I know that the period of the tangent is pi, so I can add pi to this angle. So we can find pi minus 1.14159. Actually, it's gonna be 2 because Let's check it. Pi minus 1.141. It is 5959. Okay. So theta equals 2. In this case, our complex number will be in the form, let's write again, e to the power of I times e to the power of 3I equals, we found the radius 1.8 times e to the power of I 2. Okay, yeah, we found all of them. Hence or otherwise write HOT in the form as. So what is, let's append a page in here and imaginary of e to the power of 2 times ti times, we want this e to the power of I plus e to the power of 3I. At the previous question, I can just write 1.8 times e to the power of 2I. So if you distribute it in parentheses, you will find you can write 1.8 out of this e to the power of I times 2t plus 2. From here you can write the imaginary of this complex number will be 1.8 times sine 2t plus 2. Yeah, we found it. In this case, P is 1.8 and Q is 2, right? Yeah. Question 9. Consider the differential equation dy over dx equals 2x divided by x squared plus y. The solution curve passed through the point 1, 0. Use Euler's method with a step value of 0.25 to estimate the value of y when x equals 2. Part of the solution curve is shown in the following diagram. So let's check first the Euler's method. You're gonna see on the formal booklet, and I will take this formula in here. Yeah, this one. We can use these methods to solve this question, right? This is Euler method, but just make sure that in here it's gonna be the derivative of f. Yeah, f prime. So how we gonna start? It's given us the derivative of the function 2x divided by x squared plus y, and the solution curve passed around the point 1, 0. So I can say that the initial x point is 1 and the initial y point is 0 in this case. So to find y1 or y sub 1, I will substitute these values into this equation. It's gonna be y0 plus h is a step length. I will just would like to write first the formula. And from here y1, or how we're gonna find the f prime at the point this initial is given in the question. I will just plug in into this also equation in here. So it will be f prime of 1, 0 equals 2 times 1 divided by 1 square plus 0, right? Which is 2. And then again, I'm going to do this equation Euler y0 is 0 plus the step length is given in the question 0.25 times the value that we found in here. From here you can say y1 is 0.5. Okay, so let's check the other value, the next value. It is y sub 1 plus 0.25 times. I will just write in here, since the step length is 0.25, the next x value will be 1.25 and the y value is 1.5. And now I will find in the derivative function the new values. I will apply this 2 times 1.25 over 1.25 square plus 0.5. Let's check it. Yeah, 2 times 1.25 divided by 1.25 square plus zero point 0.5. We can say 1.21. 1.21. So for y sub 2 equals uh, zero point 0.5 the y sub 1 plus 0.25 times 1.21. Okay, zero point 0.5 plus 0.25 times 1.21. Yeah, 1.21. So it is 0.8025 we can write. Yeah, or I'm gonna write in here 3. So for the next step, let's continue. Y3 will be y sub 2 plus 0.25 times f prime at the point. Now our x is 1.5 and the y value is this one, point, yeah, 803. Let's find this. And yeah, well, I'm gonna replace this one with the value we found previous. So yeah, and we can find f prime at the point 1.5 and 0.803. It will be 2 times 1.5 divided by 1.5 square plus the y value. Let's find this. 2 times 1.5 divided by 1.5 square plus 0.803, right? Let me check it again. Yeah, this one. So it is approximately, we can say 0.983. 983. So I'm gonna replace this with the value that we write in here. And so I'm again writing for y sub 3.803 plus step length times the value that we found in here. Yeah, this one. 0.803 plus step length times point this one. Let me check it. Yeah. So 1.05. Yeah. So for the next value of, we can say y sub 4 equals sub 3, the value in here, plus step length times f prime at the point 1.75, the next x value, and 1.05. Okay, so I will first find f prime at the point 1.75 and 1.05. It will be 2 times, or you don't need to write here. Oh, yeah, okay, 1.75, 1.75 square plus 1.05. 2 times 1.75 divided by 1.75 square plus the x value, the y value, what was that? 1.05. 1.05. Yeah, 0.851. And I will replace with this number in here, or plug it in this equation. 1.05 plus step length times the value that we found in here at the derivative function. Let's check this one. Yeah, times 0.851. It is approximately 1.26. 1.26. Actually, we found the value because, uh, when x is 1.25, the y value is 0.5, and when x is 1.5, the y value in here we found for sub y2 0.803, and as the x value is 1.75 and the third y value is 1.5, and then for the last one we found in here, we can say, uh, so this one is 1, 2, 3, and when the value of x is 2, so the y value is 1.26. So from here you can say x equals 2, y value equals 1.26. Yeah. At the second question, determine whether your answer to part A is an overestimate or an underestimate, justifying your answer. We can say in here, and the value is an overestimate because you see that when you're drawing tangent to the curve, it lie up of the curve, right? Yeah, or above to the curve. So we can say because the tangents to the curve lie above the curve. Yeah. Last question is justify why the use of Euler's method starting at 1, 0 does not lead to an estimate of the negative value of y when x equals 2. You can say at the point 1, 0, the tangent or the gradient of the tangent is positive and the method works at the upper side of the uh, curve, we can say. Yeah. Question 10. Rectangular playing cards are stacked in the shape of pyramids with end rows where n is greater or equal to 1. Some cards are placed horizontally and some cards are stacked at an angle of 60 degrees to the horizontal. The following diagrams represent pyramid stacks for n equals 1, 2, and 3. Let Tn represent the number of cards used to create a pyramid stack with n rows. Write down T3. As you see in the following diagram, at the first step there are two cars, and at the second step there are two plus, let's say 1, 2, 3, 4, 5, and at the third one there is 1 plus 5, and I'm using the other extra cars. 1, 2, 3, 4, 5, 6, 7, 8, right? So we can say that for the T3 equals 15. How about the T4? There's a sequence in here, you see that? So I can say for the fourth step, it's gonna be 2 plus 5 plus 8 plus 11, because it's increasing by 3. In this case, T4 will be 26, right? Yeah. And show that Tn n times 3n plus 1 divided by 2. How are we going to do that? And I know that the Tn step will be 2 plus 5, 8, 11 plus, and as you see from here, there are n terms in here. So the last term of this sequence will be 2 plus n minus 1 times 3 because I know that it's increasing by 3. So this is gonna be the last term of this sequence, right? For example, in here, this is the third term of the sequence and it is 2 plus, which is the initial point, 2 plus 3 minus 1 times 3. In this case, I will find this sum of this all terms, and it will be n divided by 2 times the first term, 2 plus the last term. From here you can write n over 2 times in parentheses, let's say 4 plus 3n minus 3. It is n over 2 times 3n plus 1. Question D. There are 52 cards in a full pack of playing cards. A complete pyramid stack is created using playing cards taken from 14 full packs. Find the maximum number of rows in the stack. Yeah, there are 52 cards and they are taken from 14 full packs. In this case, I know that's 52 times 14. Let's check it. 52, 14, 728. So the amount of the cars will not pass this number. And from here, I can say that, for example, at the end term we found in the previous question, there will be this amount of the cards. so it will not be greater than 728. Okay, and to do that, I will just write by multiplying with 2. So let's draw a graph. We don't want to pass 1456, which means, okay, let me find the intersection point. Yeah, as you can see, it is 21 point, let's say 9. So from here you can say when you draw a graph at since the intersection point is 21.9, which means that it's gonna be below this number. So you can just choose the N21. Yeah. A complete premise stack is created using plain cars taken from full packs with no cars left over. Find the minimum number of rows in the stack. So I know that there are 52 cars in a full pack of plain cars, and we want to complete a premise stack. So, for example, if there is n again rows in this premise stack, it means there are n divided by 2 times 3n plus 1 cars. But since we are using the full packs of cars and with no cars left over, it should be divided by 52, right? Which will be an integer number, or you can just say integer. So how we're gonna do that? And you can maybe simplify this a bit more. So I know that this is 2 times at the denominator, 2 times 4 times 13. From here you can say that n, for example, we can, if we choose n 4, it will be 4 times 13, but it's not, uh, it cannot be divided by the denominator. So I will increase n. You can just choose, for example, let's say uh, 13. In this case, it's gonna be 13 times 40 divided by 2 for 13, right? So you can see from here, if we choose n 13, it's divided by 52, right? So n can be minimum 13, you can say. Yeah. The last question is, the long edge of each playing card measures 88 millimeter, as illustrated in the following diagram. Find the minimum number of cards needed to create a complete prime stack with a vertical height of more than 2 meters. The thickness of the cards may be ignored. So, at the question is given that there are 60 degrees between the cards, right? I can say the angle in here is 60. So I'm looking for the height, for example, of this card. And I know that sine 60 equals h over 88 millimeter. And from here you can find h equals 88 times sine 60 degree. And I know that sine 60 is square root of 3 over 2. Let's find this, or 44 times square root of 3. 44 times square root of 3. It is 72.76.2. 76.2, we can say. This is millimeter. Be careful. And I'm looking for the vertical height of this completed pyramid stack will be more than 2 meters. So 2 meters equals 2000 millimeter, right? In this case, if I don't know how many rows are there in this complete pyramid stack, but I know that if there is, for example, n row, I will multiply it by 76.2 because at the one row, I know the height of this the one row. And it will be passed through 2000, right? And I know that n will be greater than 2000 divided by 62.2. Let's find this 2000 divided by this number. Or you can just copy this number first. 2000 divided by, yeah. It is 26.2, let's say. From here, you can say that the minimum number of cars or the minimum, let's say, row. Yeah, the minimum row can be 27. Let's calculate the number of cars, and our formula is n divided by 2 times 3n plus 1. I will just plug in 27 into this equation or formula. It will be from here 27 over 2 times 82. I will multiply 27 by 41. 27 times 41 is 1107. 1107, yeah. Question 11. In a marathon race, the random variable t represents the time in hours taken for a runner to complete the race. No runner completes the race in less than 2.25 hours, and no runner completes it in more than 7.5 hours. The probability density function for t is modeled by f, defined by, in here, the graph of f has a maximum point at t equals 4.5 as shown in the following diagram. Find the value of this integral. Yeah, we're gonna first find the value of the integral 2.25, 4.5 f of t. Yeah, down limit is 2.25 and the up one is 4.5. The function 4 over 21 times 1 minus cosine 4 pi over 9 times t minus 2.25. Yeah, this one. So it is 3 over 7. We can just write for this value 3 over 7. Write on the mod of t. As you see on the diagram, the point 4.5 has a maximum value of the probability. So this is gonna be the mod. Mod is 4.5. And the third question, determine which is greater, the mod of t or the median of t. So how are we gonna find the median? The integral of this function from 2.25 to the t, actually we are looking for the median, or you can just say it t, should be 1 over 2, right? The solution of this integral. So I will just use the previous integral that we write it here again. What was it? 2.25. I don't know actually the median, but I will just write here to the up limit is 4.5, and our function is again, let me check it, 4 over 21 in parentheses, in it is 1 minus cosine in parentheses 4 pi over 9 times t minus 2.25. Yeah, for example, the answer of this integral is 3 over 7. But if I increase the up limit to, let's say, 6, it's gonna be 0.47. And I'm increasing again, for example, to 7. It's going 0.5. It's greater than half. So I will just decrease it a bit. 4.69. Yeah, this is almost 0.5. So we can say that median is, or t is 4.69. In this case, median is greater than mod, right? Question B, let's check the question B. The runners who finish the race in 3.5 hours or less are considered to be fast runners. Find the probability that the runner chosen at random is a fast runner. So it's asking for, again, the integral from 2.25 to 3.5 and the same function. So I'm not changing the function in here and calculate it again. And the up limit is 3.59 now, 3.5. So it's gonna be 0.104. 0.104, right? Yeah. Question C, find the probability that the first runner choosing at random finish the race in 3 hours or less. So it is conditional probability. It's asked for the probability which is less than 3.5. We found it in the previous question, and it's chosen from these runners, and we are looking for the probability that the first runner chosen 3 hours or less. And I'm looking for this fraction. So what's the probability if we write the upper limit of the integral 3, and it's gonna be 0.024 or 5, this one, right? So the answer of this equation will be 0.025 over 0.104. It is 0.24. Yeah. But to not make a mistake, I will write the exact value of, for example, y the integral is uh, 3.5 first. I will just write it and calculate it again and copy this number. The number is here. It's gonna be the denominator, and the numerator will be while the limit up is 3, and I will copy this again, the number in here. So it is approximately 0.238. Okay, yeah, it's better. You can also write the probability of this number. And for the up, yeah, this one. Find the lower quartile of t. The lower quartile means the answer of the integral will be 0.25. Yeah. So if you write the function in here again, it is, I will just copy this one in here. Yeah, try to find the integral in here. How are we gonna find the integral? You can take the constant 4 over 25 out of the integral and write it in parentheses. I know the integral of this one is t, and the integral of cosine is sine. In parentheses, you can write the same value here. And I know that the chain rule, right? Uh, since it will be 4 pi over 9 from the chain rule, you can take the out of the integral or here, for example, 9 over 4 pi to cancel this value. And we're gonna write the limits of the integral and substitute them into this expression. It's gonna be 0.25. For example, when you substitute t is already gonna be the same. T minus sine in parentheses 4 pi over 9 times t minus 2.25 times 9 over 4 pi. But when you substitute 2.25, and you will see that from here it's gonna be 0. In this case, you will just subtract 2.25, which you replace here with 2.25 in here. So we're gonna find the value t from here. To do that, I will draw the graph of this function and try to find the intersection 4 over 21. X minus, you can write x minus sine 4 pi over 9 times in parentheses x minus 2.25, right? Times 9 over 4 pi, 9 over 4 pi minus 2.25. Let's check it again. Yeah, we are looking for intersection with this 0.25. And from here, you can see that it's gonna be 4.01. So t is 0. Or 4.01. 4.01, yeah. In this case, you can just mention that you found it from the graph by drawing the graph, and t was between somewhere here. Yeah, you found this intersection point, right? Yeah. Yeah. The next question is each runner's time is converted to a score which is calculated as A minus BT, where T represents their time in hours, B is greater than zero. Consider the random variable P, which represents the score of a runner. It's given that expected value of P equals 100 and the maximum possible score is 150. Use expected value of T equals 4.723 to determine the value of A and the value of P, giving your answer to the nearest integer. I will take this. Yeah, it's gonna be the question A. So this is the score. We call it P equals A minus BT, right? So if I write the expected value of P, it's gonna be equal to A minus B times expected value of T. And it's given that expected value of P is 100 and it's gonna be B times the expected value of T, which is 4.723. And there is information here. The maximum possible score is 150, which can be gained by the runner if it is the time 2.25 because I know that this is the minimum time. In this case, I will find A and B from these both equations, right? So I can replace A with 150 plus B times 2.25 and I will plug in this value in here. Yeah, minus B times 4.723. In this case, 50 equals, let's subtract 4.723 minus 2.25. Mhm. And B equals 50 divided by this number. Yeah, we're gonna calculate this number. 50 divided by 4.723 minus 2.25, it is 20.22 or just, yeah. But to not make a mistake, yeah, you can write 20.20 or 20.2. But while you are finding A, you need to write the exact value of B, which is in here, okay? So let me find this. 150 plus this value times it is 2.25, 195. Yeah. Yeah, it needs to be integer also, so it's 20. Yeah, the next question is uh given also that variance of t equals 0.906, find variance of p. So in formula booklet, the formula in here, right? This one. In this case, I can write from here uh, for this equation, for example, variance of p equals b squared times variance of t. Yeah. What is variance of t? 0.906, 0.906, and variance of p is, we're gonna find that. So b equals 20 times 0.906. Let's find this. Yeah, 3.62.5, 362.4. But again, we need to write, I guess, the integer of not integer of the exact value of p. So what was it again? It is this one, right? Let's check it again. Yeah, square times 400. No, 0.906. Yeah, 370.3. Okay. And since we're gonna write in three significance, it's gonna be 3.70. Yeah. Question 12. Consider the family of functions fn defined by fn of x. There is sigma notation in here, where x is a real number and n is a natural number. Show that fn is an even function for all values of n. So to do that, um, if I replace minus x with x, and you're gonna see that the same expression in here, I just plug in minus x, so it will be the same with f and x, because I know that the square of this minus x will be the x square, which is given at the question. So that's why this is the given, right? When f and o minus x equal the function given in the question equal. And question B, show that f sub 3 or x equals 1 minus 2x squared plus 4x to the power of 4 minus 8 times x to the power of 6. Yeah, we will just replace n with 3. In this case, I will just write, let me append the page. Yeah, this is the function here, and it asks for the f sub 3. Yeah, I replaced n with 3. So calculate this value. It's gonna be first, you're gonna replace r with 0. So it's gonna be 1 minus 2x squared because I replace r with 1. And then plus replace r with 2. It's gonna be 4x to the power of 4. And replace r with 3. It's gonna be minus 8 times x to the power of 6. Okay. And the next question is we're gonna find for f4. So now the n is 4, right? It means I will just add the expression we found before this one to, I will replace r with 4, and it will be 16 times x to the power of 8. Yeah. Consider the function f of x, limit and approach to infinity, f and of x defined over the domain. This is the domain. The largest possible value of k is the big K. Find the value of k giving your answer in exact form. Since the limit is defined, which means that the function in here, right? Or we can just write f of x, right? F of x equal limit and approach to infinity, and f n x is the sigma notation. Up limit is n. Yeah. So if there is a limit like this, or if there is a function like f of x, it means the ratio of this expression in here, the absolute value of this ratio will be less than 1. So from here you can write 2 times x squared less than 1, which means x squared less than 1 over 2, and x between 1 over square root of 2 and 1 over minus square root of 2, because I know that module of x is less than 1 over square root of 1 over 2. And so uh, find the value, which means that the largest possible value of k will be, and this number 1 over square root of 2. Yeah. At the next question, express f of x as a rational function in the form, and I know that we already found the ratio in yeah, the common ratio in here. Let's write it again. F of x is this one. Yeah. So what is the sum of this while n approaching infinity? It is 1, which is first term that we found at the previous question, over 1 minus the common ratio is minus 2x squared. And we can say 1 is the first term. Yeah, first term is 1, right? Yeah. So I can write like this, and f of x equal 1 over 1 plus 2x squared. Okay? Yeah. The function g is defined as g of x equals f of x. Justify that inverse of g exists. And at the next question, we're gonna say that g of x equal 1 over 1 plus 2x squared, right? Because it equals the f of x, and we are looking for the inverse of g. Yeah. So how we're gonna find the inverse of g? And if we equal it to the y, and we're gonna write the function in terms of y. So from here you can say 1 equals, I'm gonna make a cross product, y plus 2y x squared, and well, I'm subtracting y from the both sides, 1 minus y equal 2y x squared, and dividing by y both sides. From here you can write x squared equal 1 minus y, or you can just divide it by 2y, 1 minus y divided by 2y. So x equals either can be 1 minus y over 2y square root of this, which means that, yeah, but I know that this x is greater than 0, so I will just choose the positive one, okay? From here we can say that inverse of g of x equals square root of 1 minus 6 over 2x. Yeah, we found this. At the next question, oh yeah, sorry, we found the second one. This is the D2. In D1, it's just ask for justify that that is inverse of G. So to do that, I can just say, mm, let me check it. Append one more page. And to do that, uh, the graph of this function, let's draw this one, 1 over 1 plus 2x squared. Yeah, and we are just throwing it in the positive side, so it's going like this. Since g of x is 1 to 1, g inverse of g of x exists. Yeah. And we found the GOX, I mean inverse of GOX too, right? Mm, and the domain of this uh, inverse function, let's write the domain because we didn't write the domain. Yeah, to find the domain of inverse of GOX, I know that the domain of GOX, which means that x between 0 and 1 over square root of 2. And from here you can say that which we found in here x, in this case, the inverse of this function, we can write actually square root of 1 minus 6 divided by 2x need to be between 0 and 1 over square root of 2, okay? So our domain should be somewhere here. I mean, the x's, we need to find the x. Yeah. For example, if we draw this function, the inverse of g of x, we're gonna see this one, but we need to write the x is between, or the values need to be less than 1 over square root of 2, okay? Or first draw this and then write 1 over square root of 2. Okay, yeah. So from here you can see that our graph need to be these values, which means that x between zero point 0.5 and 1. Yeah, zero point 0.5 and 1. I'm just not taking the zero point 0.5 because it's giving us 1 over square root of 2. So to do that, you can just draw the graph or just mention that the graph of this square root of function will be here, but I am looking the place less than 1 over square root of 2. In this case, it's gonna be between like this. Yeah, this is domain. And the last question is, the region R is complete and closed by the curves GOX and inverse of GOX, and x and y-axis as shown on the following diagram. Find the area of R. So as you see from here, we're gonna first find the intersection point, so that I will just make an equality between GOX and inverse of GOX, which is 1 divided by 1 plus 2x squared. and the other one is square root of we found in the previous question 1 minus 6 over 2x. Let's find this from the graph. Yeah, this one. So the intersection point, you can say it is 0.58 or 0.59. X equals 0.59, or to make sure you will just write a bit more digit in here, and then you can yeah. So I'm gonna first check the diagram again, the graph. As you see the intersection point here until here, I will take the function g of x, but after here till the point 1, right, it's gonna be the 1 point, which is the 0 of the inverse function. I will take the integral of the inverse of this function. So first from 0 to from 0 to this intersection point, it's gonna be the g of x, plus from here we're gonna take until 1 the inverse of g of x. Yes, calculate this one. Yeah, I wrote it again, and the solution is approximately 0.635. 0.635, yeah.
Yeah, we saw all of the questions. I hope this video was helpful for you. If you need any help, please leave a comment in the comment section. And do not forget to like, share the videos, and subscribe for more content. See you in other videos. Take care. Bye bye.